Thank you very much. This was a quick switch over. So this presentation and work is done with a group that works on LOTAR. It's not in the title, but LOTAR is long-term archiving of models for simulation and verification and also requirements. My other coworkers here, I have actually personally not been so much involved, but I happen to be at the conference in the work that has been done for that. Mark Williams used to be at Boeing, and he was a chief systems engineer for the Boeing 777. So he's leading most of this effort, and he really knows on what is needed for large and complex systems. If you've ever done a really long flight, there's a great chance that you did that in a Boeing 777. It's a little bit older. They have now done a renewal cycle on that. There's a 777X, which I don't know if it's already flying or not yet. It's not yet flying fully. And the other co-workers here are RJ. RJ, he was at Modelon. He's now at Boeing. And Jose Maria Chema Alvarez Rodriguez from University of Madrid. But I will be, in the coming year, I will be working much more actively with this thing here. So why do you want to preserve model data? I have a little bit of a motivation here, why it's needed and in what industries it's needed. And then I'll give an overview over these planned LOTAR standards. So the things that I'm talking about are standards which are currently under development. And they are standards for, they are mostly process standards. And they very happily use the data standards from the Modelica Association to save them some work and give them a very solid foundation. Because they are process standards, I will give an overview over the process, and then I will talk a little bit about the tooling prototypes that have been built to prove out that this works. And then I will talk a little bit about opportunities for synergies, working more with these groups, because both sides would benefit, the process standards and the data standards, in terms of having more impact, and finish with a conclusion. Why do you want to do model preservation? Well, on this long-term archiving and retrieval of models. If you look at products which have a really long life cycle, you work with a development a couple of years, 3, 5, 10. Then you might need to store these models and retrieve them and reuse them later in the process. We've seen the V process. I mean, a large aircraft takes many, many years to do. I think if it's a new platform, at least 10 years. I don't know how long they took with the Boeing 787, the last really big one, or the A350, many years, many, many years. The total development process. But then, for many systems, transportation system, aircraft, infrastructure, the system lives for a very long time. 70 years, the Boeing B-52, the B-52 bombers, they will have a system life cycle of 100 years. They just got an extension, a life extension, because they will still be used. And that will be a system that will be from initial conception to really retiring the aircraft will have been in the air for 50 years. So business use cases for this data storage, long-term archiving is really data and model reuse, manage the risks, regulatory requirements. There are regulatory requirements which are in the wings and waiting to come, but the regulatory authorities are essentially waiting for some standards to be ready there or co-develop these things. For example, for accident investigation, if something goes wrong with an aircraft, you want to know, well, were all the decisions done properly, etc., those kind of things. For product support and modifications, you know, every few years you come up and think, well, there's new technologies, we can improve this product, but we can reuse the old models. For fixing bugs and errors, maybe there's obsolescence, you need to redesign parts because some parts don't get manufactured anymore. Support for changing tools, etc. So you need actually models that live a long time, and you can only have models that live a long time when you have standards. So these LOTAR standards, preservation is, consists of a couple of different parts. LOTAR MBSE, there are other parts of these LOTAR standards. MBSE is for model-based systems engineering, has some fancy number. No, this doesn't, it's too small from here. So 9,300, 500 is for MBSE, and it has the important part about requirement models, and number 510, validation and verification execution models, 515. I will talk a little bit about that, and we wrote more about it in the paper. 520, analysis and simulations. You see an error to something that looks awfully like a Modelica model, even though it's only a transfer function in this case, but that's fine. Architecture models, where people are thinking about, where both SysML but also SSP are contenders. Then logical bill of materials, what are all the components of the system. And then for traceability, linking all these models, what requirements, or which V&V model, for example, proves what requirements and what are the analysis and simulation models that you need for that. So if we look at how such an archive could look like, AIP stands for Archive Information something, I forgot. There is an ISO standard on how you are supposed to archive data. Archive information package. No. Yeah. And so you need, in order to do this, to use models over a long time, one thing that is very important and that we don't have data standards, or did not have, I should rather say, in the Modelica Association. We now have something with the SSP traceability layered standard. We have a data standard for that, but we did not used to have one. The metadata, meaning why was this model built? What is it for? What are the limits of validity? All these things are not documented in the Modelica model, but you need to know them if you want to reuse it after a couple of years, because without that information, you are up the creek without a paddle. How can you use the model properly if you do not know limitations and those kind of things? So, and this archive package, they are structured in such a way that there is something that tries to keep all these things together, the linking, the 550, the relationships between all these different artifacts in the model. And I will talk a little bit about that in the talk. There is, for example, there could be requirements with RecIF. Nobody is happy about RecIF for requirements as a standard, but that's the only thing that there is. But it's a different story, because the LOTAR group does only process standards. They need to use what is available on the data standard side. And for the behavior models, they think about FMI or SSP. SSP is also newer in their thinking, but it's much more useful now with version 2 and with a layered standard on top of it. So you typically would have instances of models which represent the subdomains of the MBSE models inside such a package. And then you have a header and linking all these things together. So let's quickly look at a typical process overview. A typical way to look at this is via roles and swim lanes. So what we have is at the top is a model requester. If we think about metadata that we work with in the Modelica Association, if anybody of you has seen things about SSP and SSP traceability, you have a product, you have decision makers that want to design a product, and these decision makers say, guys, I need a simulation model in order to make this decision before I have the system built. So the top level is the model requester, somebody that wants a model to make a decision. And that maps quite nicely, for example, to what was done in on the SSP traceability side for the decision level. Below that level, you have the MBSE model developer, and they could use, they could figure out whether there is actually a model for what they were asked to do, or previous model generation, and make a query to an archive and retrieve it, or they could build a model, etc. So here are the model developers. Another role in this could be a model archiver, could be the same person as a model developer, but doesn't have to be, could be somebody else. And so the archiver needs to figure out that you create something that will be reusable 10 years down the road. You have all the artifacts together and everything is properly linked. And then you also have a model consumer, somebody that picks up a model that has been in an archive, picks it up again, needs to validate that, it still works, still gives valid results, etc. So this process is what is going to be the content of the LOTAR standards. And the LOTAR people want to use, as much as possible, really useful data standards, like from the Modelica Association. So there is a relation between what is done here and what is done in the Smart SE project, for example, which has similar connections to the Modelica standards. And the model metadata needs between what the Smart SE project wants in order to get together put together a nice process, and what you need for LOTAR are quite similar. They're not 100% overlapping, but they are overlapping enough that, for example, there has been developed a mapping between the metadata for LOTAR and the metadata for Smart SE, that you have a one-to-one mapping between the top-level requirements for these things. So there is this MIG-core mapping for SSP traceability, and there's a MIG-core mapping to the metadata needed by LOTAR. There are, and so this here is really a soup of abbreviations of standards. Many are ISO standards, some are, so the SMART and AADL are architecture languages. The AP somethings all belong to are application protocols of ISO 10303. And they often describe standards for data, for automation, for the mechanical side of things, etc. Some of these, like AP233, never got implemented in tools. So that's the disadvantage of ISO standards compared to Modelica standards. We always first prove that they are necessary. They don't always do that. So, and then there are standards for defining processes. In any case, what is needed, you need to manage the process and adapt to lifecycle changes in terms of the data when there are iterations on products, and everything that is needed for a model archive needs to be updated. So I already talked a little bit about the value of model metadata. It supports model identification and creation. You really know the purpose of the model. You can find models which are similar enough. It provides all the information for observers, for initiators, for reviewers, everybody that needs to understand what was done, why it was done. It creates the context, the history. Pedigree is maybe an English word that you might not know. It's the provenance. How good is that? What's the quality of the information that is in this point? How well has this been validated? One problem with these metadata things is that there is a whole zoo of different metadata things. MOSEC is very specific for the aerospace industry. MIG-core was mostly developed on the automotive side. And then there is the metadata that's been developed for SysML traceability, decision task metadata, simulation task metadata, and simulation resource metadata. And let's say the LOTAR project hasn't really fully decided whether they're going to use them. Let's not forget that these things were only defined in a 1.0 standard a week ago, right? SSP traceability came out like a week ago, so this is not a surprise that there has been not a decision, but they are valid candidates for this. One thing that they still do, and I think they looked at the Modelica Association for that, is that they develop a little bit of tool prototypes for these things to see, okay, can this be done? Is this actually useful? And what they do is that they have use a Boeing Stratoliner model and the artifacts for that to show, does this really work? The prototype tools are just a couple of steps in this whole thing. For example, an inspection, a report that is generated to figure out, okay, when I archive a model, what's in there, what artifacts do I have, how well is it validated, and so on. And several steps in this process, there have been built prototypes, relatively simple ones, but ones to prove it. One is a LOVO tool, LOTAR validation, which has been developed by University of Madrid, Jose Maria Chema, and it provides a reference implementation for the MBC manifest and provides utilities to effectively work with these manifests. The manifests are essentially, you know, the bill of materials of what's in the models and in the artifacts and what their meaning is. Oh, I'm sorry about this small font up there. Maybe I'll upload one with a nicer one. So what can LOVO do? It can validate that all these things are actually there and cross-checks, for example, PLM data with archive repositories. And it transforms these manifests into RDF triples and LPG. So RDF is a resource description framework data and LPG is a labeled property graph. And with those things, you can make more informed queries about what is in these archives. How much? I don't see. 2 more minutes. Okay, so I didn't do my timekeeping very well. Anyways, what they do, you have lots of utilities and APIs in order to query the information in the archive package. It is done with a Stratoliner data, which is an SSP with requirements, FMUs, a behavioral model report, and linkages. You get manifest validation results. Is everything there that I expect? Yes or no. You can look at data connectivity in graph databases in Neo4j or an RDF format, which shows you really the connectivity. So what could you do with these kinds of queries in the LOVO tool? You could ask an archive, okay, give me all scenarios that have a verification credibility level of low. So which of these models were not really well verified? And then it will give you an answer and you can create these queries. And then you can use these graphs for quite complex queries. So which models are connected to which other models? You can see dependencies. You can verify common attributes and parameter values. So you can make smart queries on this. We have another prototype implementation on the 515, validation and verification. We did that in Model on Impact. Many Modelica tools do this kind of testing and checking that models give the same results as earlier. Dassault has a tool, Modelon has a tool for these kind of things, and LTX has these kind of tools. It's really about validating that a model fulfills certain things. So you have reference results and models and parameter sets and make sure all these things work together. The prototype implementation is done in Python and it checks all these things. So I think the most important part that I see here is that in terms of the current layered standards we are developing in the Modelica Association, like FMI-LS-Ref, the layered standard for reference results, there is a lot of commonality. So one of the purposes of my talk here is a call to action of more collaboration between the Modelica Association and LOTAR PDAS for further unification of the standards. And I think the Modelica Association has a great chance that these standards will become the standards that are going to be used in the aerospace industry when this will be required by regulators that you have proper data. So I think it's a great opportunity for the Modelica opportunity to extend its reach and grow by working with other standards organizations. Yeah, my conclusion then, so process standards like LOTAR for long-term archiving and system models are under development through collaboration between industry, which is PDES, AIAA, ProStab, and engineering organizations, and COSI also has their finger in it. This long-term archiving is an important use case for data standards, such as all the Modelica Association standards, and the current draft standards make heavy use and reference these standards already. Unfortunately, Modelica is not part of it. I think it would be smart. Maybe something like base Modelica would work much better for them, you know, because it's much simpler and easier to keep for a long time. And I think collaboration between the Modelica Association and PDES LOTAR Group could create further synergies on these. Yeah, that was it on my part. Thank you very much. Open for questions.